All right, let's talk about the CompTIA CySA Plus. If you're studying for it, you know that vulnerability management is a huge, huge part of it. Today, we are going to zero in on one of the most critical skills you have to master for the exam: how to analyze vulnerability scans. Let's dive right in.
So here's our game plan. We're going to start with the main goal of scan analysis. Then we'll tear apart a real report to see what makes it tick. After that, we'll get you to master the CVSS scoring system, talk about validating results, which is super important, run through a list of common vulnerabilities you absolutely have to know, and then we'll wrap it all up with a quick exam check.
Okay, first things first. As a cybersecurity analyst, a massive part of your day is going to be spent staring at reports, just like the ones we're going to look at. See, your job isn't just to push a button and run a scan. Anyone can do that. Your job is to make sense of the results, filter out all the noise, and figure out what really needs to be fixed right now. And that's the key right there. For the CySA Plus exam, and honestly for the real world, it's all about turning that giant mountain of raw data from the scanner into smart, prioritized, actionable intelligence. It's about knowing what to do with the results. That's what separates a real analyst from someone who just runs a tool.
So to get that intelligence, you've got to know how to read the map. And in our case, the map is the scan report. Think of this next part as a guided tour. We're going to break down a typical report from a tool called Nessus, but honestly, the layout and the concepts are pretty much the same no matter what scanner you use.
So here it is, a classic Nessus report, and it is packed with info. Let's walk through the parts you'll look at every single time. First up, you've got the description. That tells you what the vulnerability is in plain English. Then you have the solution, which tells you how to fix it. In this case, disable some old protocols. The risk information is super important. That's where you find the CVSS score that tells you how bad this is. And maybe most importantly for checking if it's real, the output section gives you the raw data, the proof of why the scanner flagged this.
Okay, let's zoom in on that CVSS score we just mentioned. This is the industry standard for rating vulnerabilities. It's called the Common Vulnerability Scoring System, and it's how we turn a simple finding into a clear, numerical rating of how severe it is.
At its heart, CVSS is just a score from 0 to 10. You see a 0, it's no big deal. You see a 10, well, that's the drop everything and fix it yesterday kind of problem. But the real magic, the part you need to understand, is how that score gets calculated. It's based on 8 very specific metrics.
And boom, here it is. This is basically an exam tip straight from the source. This is your study guide for this section. You absolutely positively have to be able to look at all of these metrics and know what they mean. So let's break them down right now.
Okay, the first 4 metrics tell us how easy it is to exploit this thing. Attack vector basically asks, how does the attacker get in? If it says network, that's bad news. It means they can attack you from anywhere on the internet. Attack complexity asks, how hard is it? Low means it's super easy. Privileges required tells us if the attacker needs to be an admin already. None is the worst case scenario, meaning anyone can do it. And finally, user interaction asks, does a real person have to click a bad link? If it says none, the attack can be completely automated.
Next up are the impact metrics. This is all about the damage that gets done, and it follows the classic CIA triad you've heard about: confidentiality, integrity, and availability. These tell you what the attacker gets if they succeed. Can they steal all your data? Can they shut the system down? And then there's the scope metric. This one asks a really important question. Can this vulnerability be used to attack other parts of your system? If the scope is changed, the overall score gets a serious bump.
So all those metrics get smashed together into what's called a vector string, and it looks just like this. For the CySA Plus exam, you need to be able to look at this and just decode it in your head. AVN, oh, that's attack vector network. ACL, attack complexity is low. CI, confidentiality impact is high. This string is like a secret code that tells you the entire story of the vulnerability. Getting this is not optional for the exam.
Okay, so you've got your report, you've decoded the CVSS score, and you know how bad it is. But hold on, you're not done yet. The next step is absolutely crucial. You have to validate the results. You know, scanners are just tools. They make mistakes. And you can't afford to have your team waste days chasing ghosts.
This right here lays out the 4 possible outcomes of any scan. A true positive is great. It's a good catch. The scanner found a real problem. A true negative is also good. It correctly said, hey, everything's fine here. Now, the problems are the errors. A false positive is when the scanner cries wolf. It says there's a problem when there isn't one. It's annoying and wastes time. But the really dangerous one, the one that can get you fired, is a false negative. That's a critical vulnerability that your scanner completely missed. Knowing the difference between these is a must for the exam.
All right, time for a rapid fire round. A big part of analyzing scans is just pure pattern recognition. So let's blast through some of the most common vulnerabilities that you are guaranteed to see on the CySA Plus exam and out in the real world. Think of these as your digital flashcards.
First up is a true classic, the buffer overflow. Basically, an attacker sends way too much data to a program and it spills out of its designated memory space, overwriting other important stuff. It's like pouring a gallon of water into a tiny cup. For the exam, you've got to know the two main flavors. Stack overflows mess with the program's flow, while heap overflows corrupt its data. Either way, they can be devastating.
Next, we have privilege escalation. This is what every attacker dreams of. They find a way to get on your system as just a normal, everyday user, but then they exploit a flaw to become the administrator, or root. They go from being a guest in the house to owning the whole building. The famous dirty cow bug in Linux is a perfect example of this in the wild.
Now, this might just look like a bunch of gibberish, but this is a classic, deadly SQL injection attack. An attacker types this into a search box on a website, and if it's vulnerable, it tricks the database into running a secret second command. In this case, hey, give me all the customer names and credit card numbers. It's incredibly effective and still works all the time.
Cross-site scripting, or XSS, is a tricky one. It's where an attacker injects their own malicious code into a website you trust. Then, when you visit that website, your browser runs their code, potentially stealing your cookies or login information. For the exam, they specifically want you to know the difference between persistent XSS, where the bad code is saved on the server, and reflected XSS, where it's usually in a link someone tricks you into clicking.
And here are a few other heavy hitters you just have to be able to recognize on site. End-of-life software is a giant red flag. It means it's not getting security patches anymore. Cryptographic failures, like using ancient SSL, mean your private data is flying around in the clear. And of course, the one that makes every security pro shudder, remote code execution, or RCE. That's game over. It means the attacker can run any command they want on your server.
Okay, we have covered a ton of ground. Let's put it all to the test and see if it's sinking in. We've got a sample question for you that's built exactly like something you'd face on the actual CySA Plus exam. Ready?
Okay, take a look. Our analyst, Tara, checks out a vulnerability that the scanner reported. But when she investigates, she finds out the system is already patched, so the vulnerability isn't actually there. What do we call that type of error? Take a second and think about it. And the correct answer is B, false positive. If you got that, nice work. A false positive is exactly that. The scanner raises an alarm about a vulnerability that doesn't actually exist. This is a perfect example of why an analyst's job is so important. You have to manually validate these things. And that brings us to our final thought for today. Something to really chew on as you prepare. For your exam, and more importantly, for your career. Which is actually more dangerous? A high-severity false positive that makes your team waste a whole day investigating nothing, or a critical false negative, a real, ticking time bomb of a vulnerability that your scanner missed completely? That question right there, that's the core challenge of vulnerability management.